Draw graphs. Shopping. For every 2 pairs of earrings you buy at the regular price of $29 each, you get a third pair free. So you can ignore these mess-ups in the background. There's something with the printing going on. So the first thing we're told is to make a table showing the cost of buying 1 to 5 pairs of earrings. Now get a ruler out and give yourself a little bit of distance, if this is the left side of your paper, to where you're drawing a line about here. So taking that ruler, give yourself a decent looking vertical line and set up, what some people call like a T-chart. And then sketch that line or make it with your ruler as well. Now, it looks to me like the independent variable is going to be the earrings. So maybe here I just put like ear. And then over here I'm going to put a $sign to represent the cost. And if I wanted to be more specific, I could be like, well, the cost. And then afterwards, in parentheses, showing what the units would be, which would be dollars. And you do things like that with like kilometers and distance as well. And since they are really making us do this for 1, 2, 3, 4, and then 5 earrings, and I can extend my table down, we're going to figure out what this is going to cost. Now I jump back because this is a little bit different of a type of problem. For every 2 pairs of earrings you buy, at the regular price of $29 each, you get a third pair for free. So that means my first one is definitely not free, and I'm not going to bother putting a $sign here because it's suggested that that's happening again and again because on my right side of my table I see the $sign. So I'll put 29, and I can double that pretty confidently, but if not, I'd type it into the calculator and put 58. Now I'm showing the cost of buying 1 to 5 pairs of earrings, but having bought these first two, the difference is this third one would actually add $0 on. But I would not just add on and write the number 0 here. I would rewrite 58 because that would represent that I paid for this one, I paid for this one, but then getting the next one for free, there's no change. So this is not going to look like your typical straight line graph. It's like it's going to grow and then all of a sudden flatten out and not change from one step to the next. But after I get that third one free, that means that moving on to the 4th pair of earrings and the 5th pair of earrings, I'm getting another 2 that I have to pay for. So you can go ahead and add 29 twice and see if you get the same next 2 numbers that I do. So I got 87 and 116 for the next 2 rows. And really this person should be getting that 6th pair as well. Like hopefully they're not totally incompetent and realizing that, hey, you got a free one coming to you. Now this next step says write the data as a set of ordered pairs. And I guess, in our homework you're going to have your lines and maybe you're going to want to go ahead and just graph this as a list of numbers. So maybe I'm like, well, if I buy 1, it's 29, 2, 58, 3 is still at 58, and there's somebody who is compensating for something by driving a loud vehicle in my neighborhood right now, so that's really cool as I'm trying to make this math video. I guess I shouldn't expect the world to be quiet while I make these things, right? At least it's not the bell system at school. So here I have the data as a set of ordered pairs, and I've written them as a list, separating them by commas, and note that I have to sneak those in between each set of parentheses to make it look neat and stand apart from each other. Okay, now there's no negative numbers or anything like that, so when I go ahead and I graph this, I'm not going to bother giving myself the 1st, 2nd, 3rd, and 4th quadrants. I'm really only interested in something in the positive direction. So as you set up your y-axis, I want you to be using a ruler so that yours look neater than mine. And my arrows are going on forever because there's no end to any of these numbers. Now, they tell us that we're going to go from 1 to 5. This would be our x-axis, and I'm going to label that as earrings. Now, where I wrote ear earlier, I only wrote that because I'm just going to write earrings here because I got the room to do it, and also graphs, should be representative of what's going on. I'm sneaking a Y right there to label the y-axis, and then over here maybe I turn my page and I'm going to write cost, and this is going to be in dollars. And the reason I point that out is that You know, maybe these earrings over here, this could be like in thousands of units or something. So there are times where you'd like even label your standard counting deals. Now the earrings only go up to 5, so I'm going to make use of all that space, and then with 5 I gauge where I think 1, 2, 3, and 4 should be. I don't bother labeling those because I think it's pretty inherently clear what's going on there. But here I'm going to look at this and say, okay, well, how far should I go up in my y direction? If I want to cover all 5 of these points, I need to go up beyond 116. Okay, and that means that maybe I go all the way up to something that stops at 25s. So how about 125? So in my head, maybe I really wish this was just easy to stop at 100 because that would be a lot nicer. But I'm like, okay, cool. If I stop at 125, I can count up by 25s. So I'll say 25 while counting on my fingers each step along the way, 25, 50, 75, 100, 125. Well, that's 5 total stops. So here's my 5th stop, a bigger increment mark for 100, and then 4 in between those. So this would be 25, 100, 75, 100, and then 125. Cool. Okay, so after I buy 0, I spent no money. Don't forget about that. So this should be right there at the origin, 0, 0. 0 earrings, you're going to pay no dollars at all. But if I get 1, that puts me somewhere here around 29. 2 puts me somewhere here at about 58. And that should be a straight line between those 2 points. But then the interesting thing is at 3, there's no change. There's 358. Now notice I just said 358 as a coordinate, as an ordered pair. And then I'm over at 487. And I'm, in my head, I've done this a number of times, so I'm tracing back to the axes and seeing where I think this should be. And then my 5th point is going to be 5, 116. And when I connect these, those would be straight lines that would neatly go through those points, and these would be straight lines that would go through the 4th point. And if this were to continue, it would keep on going like that, like stepwise. So this would be everything that they asked us to do, and then we graph the data. And if I were to be doing this for a science class or something else, I'd probably be like the cost based on the number of earrings you purchased, and be a little bit more specific and detailed with the heading that I put above my graph. So yeah, it's really important that you try to do steps in between before always going straight to your graph, especially if the problem's loose and open-ended, because building a table is a real nice way to try to picture things, as opposed to going straight into the end result. Alright, suppose you earn 25 cents for each book that you sell. Make a table showing how much you earn when you sell 1 to 5 books. Now, unlike the last one, there's no weird stepwise deals going up, and then they were told to write the data as a set of ordered pairs and graph it. So I'm going to make this an OYO problem on your own, and then I'm going to go ahead and fill everything in about 5 seconds. So make sure you pause this so that you can hear me talk about it after you've done it and not try to be catching up so quickly. So I have my table set up, and now if you didn't use the exact same word as profit, that's fine. Like if you used earnings, that's cool. But if you just put money, that's probably not specific enough. And since my units are in dollars, I should have a dollar sign here. So I also just set my ordered pairs up directly there, because that was like a nice tracking thing. There's 125, and I was able to just set it up exactly there. And then with my graph over here on the x-axis, I would have books all the way up to 5 for this, and then profit going from 0 to $1.25 roughly. So I just stopped at $1 because, it's not that big of a deal, and there's these increments of quarters are so much easier to work with than these increments of 29.58 because of where they stop at. I drew this line perfectly straight, like it didn't really go through this point here. And so think about the purpose of this. Well, we're doing like a classwork assignment, we're doing a homework assignment. It's not like we're using this to be purposeful a moment from now, like interpret our data. It's not like it's saying, hey, if you were to sell 125 books, how much would you make? Or when would you break even? Or different questions like that. The more involved the question is, then the more accurate you want to be in your graphing, but we're good right here. And I just want to point something else out. Notice that I've drawn arrows at the end here. I don't want you to overthink that for this problem, because really it's not like we'd be going into the negative book direction. But later on when we're working with things like slope and x and y intercepts, we'll probably end up moving more towards the abstract when the lines are really more purposeful than the actual real-world problem that we began with. But now that this problem's pretty much over, that does kind of lend itself towards talking about domain. Well, if I'm thinking about domain is all my x inputs. So if I thought about having a -1 book, that would not really be within the domain of this problem. And these are in red, so don't write this stuff down. I also wouldn't sell 1/2 of a book, so that would not be in my domain. So if I were thinking about domain for this problem, it would be whole numbers counting up, starting at really 0, all the way up to, I guess, 1 trillion. Who knows how many books you could sell, right? If this were Amazon, I guess you could sell a lot. And then that would be domain. Now, you don't have to write any of that down. But if I were to talk about range, that would be my y direction. Well, in this case, based on this problem, I'm not owing any money, so there's no such thing as negative values here in this problem. But unlike the domain, it might be possible for me to make decimals, so starting at 0, 0.25, 0.5, that would be the range. And so that's a memorization thing, domain and range. But as we're filling in our notes, you're going to want to make a note that domain is all the x, and then range is all the y. And x comes earlier in the alphabet, and y comes later in the alphabet. So as these have always been talked about, we're pretty much in the habit of hearing about those things as x and then y. And when we talk about domain and range, anybody that's practiced with this as a teacher should really be saying domain and range habitually. So you would hear domain first, and hopefully that lets you, grab a hook of the fact that, well, domain's always going to be x. The other thing I like to think about is well, I live in my domain. And if I were a lion, I would govern my domain. And that's the stuff that's closest to you. Whereas if I were out on the prairies, I'd be looking out onto the range. So that's my kind of vocabulary, strange, peculiar way that I have of trying to use my eyeball and, seeing amazing things beyond this world. What else is there? Who knows? No, I'm not really serious. But what I am saying is that if you think about range, and you're looking out on the range, that's further from you, and the y-axis is less close than x. Okay, so now I'm just going to jump into the problem first. It says identify a reasonable domain and range for this situation. So I'm going to put a capital D, colon, and then a capital R, colon. That's usually how we denote domain and range. And the reason I'm going to point out this beforehand is just so we can think about the word reasonable. If this were Netflix viewing, I would never watch negative hours of Netflix. But I could watch 10 minutes, so therefore I could watch a 6. So fractions are totally cool there. If this was, output of money, then really there'd be almost no limit on the range. I could really owe somebody a ton of money and be very in debt. So maybe later on in life when you're doing these problems, you might have a range of negative infinity all the way to positive infinity. And not just for that, but also for the domain. So let's go back to the word problem. Rasha rides her bike an average of 0.25 miles per minute, up to 36 miles each week. The distance that she travels each week is a function of the number of minutes that she rides. Now, let's focus on the wording of this because it's more challenging. The distance that she travels is a function of the minutes that she rides. So it sounds to me like the distance is functioned based on the minutes that she rides. But the other thing I'm probably thinking to myself is I'm very used to time being on x-axis of a function. So maybe that, combined with the way that I would think about the wording of this, helps me realize that my time is the domain. Now, it's not like she's going to travel back in time in this problem, but she could maybe get injured and step off the bike and be like, well, I didn't get to ride at all this week. So she might ride anywhere from 0 all the way up to, well, what would be a reasonable total number of minutes that she could ride? Well, I guess we would go based on the numbers they give us. So she averages 25 hundredths of a mile per minute, up to 36 miles each week. So that means well, if she can do 25 hundredths of a mile per minute, you might be tempted to be like, well, I guess I'll divide 36 by 4 and get 8, you know. Not 8, because that would not be right at all. I'm way off there. It would be 9. But then, like, does that seem reasonable that she could ride her bike 36 miles in 9 minutes? So, like, if you ever start off in the wrong direction, you might be like, well, shoot, I guess I got to, you know, not just take a fourth of that. But really, I'd be timesing 36 by 4. So over here, I'm going to do 36 times 4, and I'm going to get 144. Now, that was a little bit of a logic reason. But let's, like, plant a little seed for stuff that's going to come later on. So think about this way. She's traveling 0.25 miles per 1 minute. Now, let's say I wanted this to be multiplied by the 36 miles that we have going on. Well, look at this. Do our miles cancel out with anything? If they were down here, they would, and that's a problem. That's not going on. So I went down the wrong direction on purpose, and I'm like, well, if she's going to travel 36 miles, and I want to multiply by some sort of conversion, then maybe I put the 0.25 miles down here, and the 1 minute up here. And the nice thing about approaching it this way is that the miles cancel out, and I'm really left with 36 divided by a fourth, which will end up giving me that 144 miles. So she might travel anywhere from 0 to 144 miles. Now, they're giving you something where you're dividing by a decimal in this problem. So this is more challenging than I would give you in the quiz in the near future, especially since we haven't dealt much with conversions or anything like that so far this year. So domain 0 to 144, and I can put the word minutes. I'm sorry,